Dear student, myself Dr. Deepak Verma. Today we will discuss the practical problem to design anchor sheet pile using fixed earth support condition. The problem is compute the embedded depth and pull in the anchor rod for the sheet pile of height 8 meter above the line. The position of anchor rod is 2.5 meter below ground level and the given phi 35 degree and gamma 16 kN per meter cube. Assume fixed earth support condition. First of all, draw the pressure distribution diagram. As shown in figure, it is a pressure distribution diagram where A, B, G, it is sheet pile, where A is a point at ground level, B at dredge level, and G it is a point of fixity. The height of sheet pile above dredge line, it is 8 meter. I, it is the point of inflection. D, it is the zero pressure point. First of all, determine the coefficient of active and passive earth pressure by using the formula 1 minus sin phi upon 1 plus sin phi, and Kp is the reciprocal of K. The value of K for given value of phi 35 degree, K is 0.27 and Kp 3.69. Then determine the earth pressure at dredge line, that is Pa, by using the formula Ka gamma h. By putting the value of Pa 34.6 kN per meter square. Then determine the depth of zero pressure point, that is x, from the triangle, this one. Here we know the value of Pa, that is 34.6, and unknown is x. Then using the equation we can determine the value of x by putting the value of Pa, gamma, Kp and K, and the depth of zero pressure point is 0.63. Then determine the value of y, that is the distance of point of inflection below dredge line. We can determine the value of y from the chart. For given value of phi 35 degree, the ratio of y by h is 0.025 and the value of y is 0.2 meter. Further, divide the sheet pile in two beams, upper beam and lower beam. Here the upper beam is AI and lower beam IG. For upper beam, determine the value of P dash at point of inflection, that it is a dotted line. We can determine the value of P dash by using the value of Pa, by using the value of x, and by using the value of x minus y. From similar triangle, if we consider this triangle, Pa, it is the earth pressure, and x, it is the distance from zero pressure point. Similarly, P dash, it is the earth pressure at point of inflection, and distance is x minus y. So by using this relation of similar triangle, P dash equal to Pa into x minus y upon x. By putting the value, the P dash is 23.6 kN per meter square. Then by taking moment about F, it is a point of anchor rod as shown in this figure. By taking the moment about F and equating 0. So there are three forces. First, about dredge line from right to left. Second, for this rectangle, and third for this triangle. So by taking the moment, force into distance, first of all determine the force and then what is the perpendicular distance of point of action to the anchor rod. It is the area of triangle above the dredge line, half base into height. Half 34.6, it is the value of Pa, and 8, it is the height of sheet pile. Multiply with the perpendicular distance from Pa, point of action, to this F. We can determine from top 2h by 3 it is a point of action 2h by 3 and then subtract this 2.5. Then second, it is a rectangle. For this rectangle the side is 23.6 and another is 0.2. So area is 23.6 into 0.2 multiply with the distance from this f. The distance is from f, it is up to b, it is 5.5, and from b it is half of 0.2, so it becomes 5.5 plus 0.2 by 2. Third, again it is a triangle. The base, the difference of 34.6 and 23.6, so it is the base into height is same 0.2, half base into height. And what is the point of action from this f? From f it is up to b it is 5.5 and from here it is h by 3 where h is 0.2, so it becomes 5.5 plus 0.2 by 3. And one more force, that is Ri, that is reaction at point of inflection, and the direction of this Ri is opposite as compared to the other forces, so the sign is negative. Point of action again Ri up to Fa it is 5.5 plus 0.2. After simplifying the force, it is 138.4 into distance 16 by 3 minus 2.5, second 4.72 into 5.6, third 1.1, it is the force for this triangle and the distance is 5.5 plus 0.2 by 3. From here we can determine the value of Ri, that is 74.4 kilonewton. Now use this value of Ri for the lower beam and then determine the value of D dash. By considering the lower beam, that is Ig, first of all determine the value of P2, that is the earth pressure at base, by using this formula. By putting the value of P2 is 54.7 into D dash minus 0.63. Now by taking moment about base of sheet pile, that is G, and equating to 0. So first of all Ri and the distance from Ri up to this, it is D dash minus Y. Then second, for this small triangle, for this the base is 23.6 and height is 0.3, so the area becomes half base into height, half 23.6 into 0.43, and the point of action of this triangle up to G point, it is D dash minus X, that is from here to here it is D dash minus X, plus for this triangle it is 2h by 3 where h is 0.43, so it becomes 2 into 0.43 by 3. For third one, now the direction is opposite, so the sign is negative. Again half base into height, base is P2 already determined and the height is D dash minus X, so it becomes half base into height, half base 54.7 into D dash minus 0.63, that is X, multiplied by height D dash minus 0.63 into point of action from G, it is h by 3, so it becomes D dash minus X by 3. So in this equation D dash minus X is repeating, so we can assume D dash minus X as A. So by assuming D dash minus 0.63 as A, then the equation becomes Ri into A plus 0.43, second term half 23.6 into 0.43 multiply by A plus 2 into 0.43 by 3 and minus half 54.7 into A3 by 3. By simplifying this equation, the equation becomes A cube minus 8.74A minus 3.68 equal to 0. it is a cubic equation. By trial and error, we can determine the value of A, which is 3.15. By putting the value in this equation, we can determine the value of D dash, and D dash is 3.78. So the design depth, it is 20% more than the D dash. So D equal to 1.2 T dash, that is 4.536 meter. So the design depth is 4.54 meter. Next, what is the force in anchor rod? Now, by considering the upper beam, we can determine the forces Fa, the force in the tie rod, active earth pressure, and it is a reaction at point of inflection. We know the value Ri, that is 74.4, and active earth pressure, it is sum of three forces as already determined. So 138.4 plus 4.72 plus 1.1. By simplifying, the value is 69.8. So the force in anchor rod is 69.82 kN. Similarly, we can determine the other problems also by following these steps. Thank you.